Okay, we've seen inequalities on a number line. Now we're going to show inequalities on an XY graph, or XY plane as it's called. So here's our first inequality. Well, it's saying x is greater than -3, but x is also less than 4. Now the first thing we do is we work out where are the boundary lines for this region. And the boundary lines are given to us by letting those inequalities become equal signs. So the first boundary line is x equals -3, and that's a vertical line through the point where x equals -3. So you have to understand why x equals -3 is that vertical line. And the reason is because every point on that line has an x coordinate that is -3. So that point there would be -3, 0. That point there would be -3, 2. This point here would be -3, 5. So on that line, the x value is always -3. And similarly, for x equals 4, there's the boundary line for x equals 4. And the region that we want is x between -3 and 4, so that would be that region there shaded in. In example 2, this time we have y, not x, it's y, which is between -2 and 5. So once again, we turn those inequalities temporarily into equal signs to give us the boundary lines. So our first boundary line is y equals -2, and our second one is y equals 5. Y equals -2 is down there. The reason why that is the line y equals -2 is that every point on that line has a y value of -2, and for the second boundary line, every y value there has a value of 5, so that's the line y equals 5. Now our inequality is telling us y needs to be between -2 and 5, so that would be that region there. There's just one last thing to think about, and that is the inequality at the top there is y isn't just less than 5, y could actually equal 5. And we demonstrate y equaling 5 by turning the broken line into a full line like that. Okay, so that's our region. Y is greater than -2, and at the same time, y is less than or equal to 5. When the inequality involves a non-vertical or non-horizontal line, there's just a little bit of added detail that we need to take care of. So here's our example. Y is less than x plus 3. Once again, we turn that into an equation, which is y equals x plus 3. In order to do that, we need some points to plot our lines. So pick some x values and find the corresponding y values. So the first x value I've chosen is x equals 0. It doesn't matter why I've chosen 0. I could have chosen x equals 1 or x equals 2, but I've chosen x equals 0. If you put x equals 0 into there, you get y equals 0 plus 3. So that's why you get y equals 3. So now we plot the point 0, 3, and there it is. For another point, choose another x value. I've chosen x equals 2. If we put x equals 2 into the equation there, you get y equals 2 plus 3. So that would give us y equals 5. And now we plot the point 2, 5. And a third x value, I've picked -2, put -2 into the equation. So then y would equal -2 plus 3, which is where we get y equals 1 from. And so that's our third point, and that gives us the line y equals x plus 3. Now, the region is y is less than x plus 3. So in order to find, we're going to either shade this side of the line, or we're going to be shading this side of the line. And we test with one point that's not on the line, and the easiest point to pick is the point 0, 0, because we want to know, is the point 0, 0 part of the region, i.e. this side of the line that we want to shade, or is it not part of the region, in which case we would want to shade this side of the line. So what we do, we take our values x is 0 and y is 0, and we substitute them into the inequality. So y less than x plus 3 now becomes 0 less than 0 plus 3. And is that true? Is 0 less than 3? Yes, it is. And that means that the point 0, 0 fits the inequality, and therefore that is part of the region that we require. We now look at the boundary line, and our original inequality doesn't allow for or equals to, so our boundary line is just a broken line, as we can see. Here's another example. Here's another region. Once again, we take the inequality, turn it into an equation. So we want to plot the line y equals x subtract 1. So we pick an x value. When x is 0, stick it into there, and you get y equals 0 subtract 1, which is negative 1. So that's the point 0, negative 1. We then choose a second x value. X is 3. We put x equals 3 into there, and you get y equals 3 subtract 1. So that gives us y equals 2. So we plot the point 3, 2. And when x is negative 1, y would equal negative 1 subtract 1, which is negative 2. So we plot the point negative 1, 2. Sorry, negative 1, negative 2. So that's our line. Now, I don't know if you remember from the last example, we then choose one point not on the line, and the easiest point to pick in this case would be the point 0, 0. We put 0, 0 into that inequality, i.e. y is 0 we put into there, and x is 0 we put into there. And that gives us 0 is greater than negative 1. Is that true? Is 0 bigger than negative 1? Yes, it is. And that means that this point here, that we picked the origin, then that point fits the inequality, so it is that side of the line that we shade. And then lastly, we have a thought about the boundary line. The inequality is a strict inequality, so we use a broken line. And finally, y is greater or equal to x plus 1. We draw the line y equals x plus 1. And I'll just go through this reasonably quickly in the hope that you've picked up how to pick our 3 coordinates. So that's the first coordinate. 3, 4 would be another coordinate. And negative 2, negative 1 would be a third coordinate. So we join up those points with a broken line. Once again, we pick a point not on the line, and we're going to pick 0, 0 again. We put 0, 0 into the inequality. What do I mean by that? Y equals 0, we replace there. X equals 0, we replace there. And that gives the inequality that 0 is greater than 1. Now, of course, 0 isn't greater than 1. So this time the origin, the point we picked, doesn't satisfy, doesn't fit the inequality, and therefore it must be the other side of the line that we want, and hence we shade that side of the line. And one last detail, we check that that inequality allows for y equaling x plus 1, and therefore we use a full line, not a broken line. So here's a checklist of what you need to do. Change the inequality into an equation for the boundary line. plot points to draw the boundary line, test with one point not on the boundary line, shade the region required, and then finally check whether the boundary line should be broken or full.